Namaste to everyone. I welcome you all in my YouTube video channel. Today, I will deliver lecture on linear algebra, chapter minimal polynomial and minimal equation of a matrix. Lecture number 3, in which I will prove some more theorems of this chapter. Now we prove a theorem. Theorem is the minimal polynomial of a matrix is a divisor of every polynomial that annihilates this matrix. Now we prove this. Let mx be the minimal polynomial of a square matrix A of order n. Therefore, mx annihilates the matrix A, implies that MA equal to 0 matrix. Annihilates matrix A means if we replace x by A, then we get a 0 matrix. This is number 1. Let hx be a polynomial that annihilates the matrix A, implies that HA equal to 0 matrix. This is number 2. We know that the minimal polynomial of a matrix is the lowest degree monic polynomial that annihilates the matrix A. Therefore, degree of mx is less than or equal to hx. By division algorithm, we get that hx equal to mx multiply another polynomial qx plus rx, where rx is a polynomial that may be 0 polynomial or a polynomial of degree less than the degree of mx. Let this is number 3. Replacing x by matrix A in theory, we get HA equal to MA multiply QA plus RA. This is number 4. Using 1 and 2 in 4, we get this is 0 into 0 matrix. This is 0 matrix in 1 QA plus RA implies that RA equal to 0 matrix. This is number 5. From 5, we get that Rx annihilates the matrix A. Therefore, a polynomial Rx of degree less than the degree of the minimal polynomial mx that annihilates the matrix A, which is against the definition of minimal polynomial of matrix A. Therefore, Rx will be a zero polynomial. That is, Rx equal to 0. This is number 6. Using this value in theory, we get Hx equal to Mx multiply Qx plus 0 implies that Hx equal to Mx multiply Qx implies that Mx divides Hx implies that the minimal polynomial is a divisor of any polynomial that annihilates the matrix A. Proved. Now we prove a corollary. Corollary means on the basis of the previous theorem we will prove this statement. Statement is the minimal polynomial of a matrix is a divisor of characteristic polynomial. Now we prove this. Let mx be the minimal polynomial of a square matrix A of order n. Therefore, mx annihilates the matrix A, implies that MA equal to 0 matrix. This is number 1. Let fx be the characteristic polynomial of the matrix A. Then by Cayley-Hamilton theorem, we get that if A equal to 0 matrix, this is number 2. Therefore, the polynomial fx annihilates the matrix A. We know that the minimal polynomial of a matrix A is a divisor of any polynomial that annihilates the matrix A. Therefore, mx is a divisor of fx, implies that the minimal polynomial of matrix A is a divisor of this fx is characteristic polynomial of the characteristic polynomial of matrix A. Proved. Now we prove corollary 2. Corollary is every root of the minimal equation of a matrix is also a characteristic root of the matrix. Now we prove this. Let mx be a minimal polynomial of a square matrix A of order n. The minimal equation of A will be mx equal to 0. This is number 1. Let lambda be a root of this equation, implies that m lambda equal to 0. If lambda is a root of this equation, then we may replace x by lambda. This is number 2. Let fx be the characteristic polynomial of matrix A, and fx equal to 0 is the characteristic equation of matrix A. This is number 3. Since we know that mx and fx both annihilates the matrix A, implies that M A equal to 0 matrix and F A equal to 0 matrix. Also, we know that the minimal polynomial of a matrix A is a divisor of any polynomial that annihilates the matrix A. Implies that minimal polynomial mx divides characteristic polynomial fx. Implies that fx equal to mx multiply qx. This is number 3. This is number 4. Replacing x by lambda, we get f lambda equal to m lambda multiply q lambda. Implies that f lambda equal to m lambda equal to 0 multiply q lambda using 2. Implies that f lambda equal to 0. Therefore, lambda is a root of fx. Since we have assumed that lambda is a root of mx equal to 0. Let this is number 5. Therefore, from 2 and 5, here 2 lambda is a root of minimal equation, and in 5 lambda is a root of the characteristic equation. We get that every root of minimal equation of a matrix is a characteristic root of the matrix. Proved. Thanks for watching my video. If you are satisfied with my presentation and contents, then please click on like button. And if you have not yet subscribed my YouTube channel, then please subscribe my YouTube channel. Thank you.